Good morning or good afternoon, everyone. It seems like it's been a while since we've seen each other. Hopefully, you've been able to make some progress. And also, hopefully, you've been able to get some emails and information from me. If you're watching this, you probably have. Just to kind of recap a few things, um, our goal is to pretty much stay the course for now, which means we're going to make progress through our geometry unit. At certain times, I will post some worksheets for you to work on. You can either take pictures or scan them and get them back to me so I can get a little feedback. There is a little bit of change in testing. At one time there weren't going to be IB tests, and now there might be some modified versions. So as that becomes more clear, I will be letting you know. So our goal is to continue making progress through the geometry unit. Once I feel that we're done with that, I will post some type of an exam or test. And then after that, it's pretty much getting ready for whatever the test may look like. We do have a little bit of statistics to talk about, calculus, but really want to focus on the geometry here for the next few weeks. Right before spring break, on your own, I ask you to basically look at L and M. L, you might remember, involved distance and locus. Describing the locus is simply just a set of points with some characteristics and requirements. And then on section M, we had work with the circle. And I think you know a lot about the circles. It would be interesting to maybe continue to go back to those problems, even though we're going to be moving on to some other conics. I am not going to try to totally replace what we typically do in class. It's kind of hard to do that. I am going to rely on you to read the text, study it. You can make sense of it as much as I can. If these videos really don't help you much, that's fine. One thing I will try to do is highlight some of the big areas, which is pretty much what I've been doing in class. So study them, look at some samples. When I do send out worksheets, work on those. See me or ask, not see me, but let me know if you have some questions, and I'll try to help out as much as I can. So this quick little lesson here in section N is going to be about conics. All right? And we know the idea of conics. We can think of it geometrically with a cone and a plane slicing the cone, and we're either going to get a circle, parabola, hyperbola, or ellipse, depending on how we slice it. We have the locus definitions of the conics, and the locus definitions involve, for example, a circle, a set of points in a plane equidistant from a fixed point. All of the points that hit those requirements would lie on a circle. We have similar things for each of the others. One thing I want to point out is that in this course and at this level of mathematics, one thing we sometimes focus on is this thing called the eccentricity, or N, or E, sorry. So what I want to do is get a little picture of that and talk about it. If I have some line in some point, because pretty much all conics can start with a line and a point, okay? Except maybe the circle, because that's unique. And then if I have some point out in space somewhere, and it's a certain distance from the point and a certain distance from the line, which of course has to be measured along a perpendicular always, we basically have described what we call this thing called eccentricity, or just E. And it's the relationship of PF to PN. So even if you discuss conics in previous courses, eccentricity was probably not presented quite in this way. So that's eccentricity. And based on that relationship, we basically know if we have an ellipse, parabola, or hyperbola. If that E is somewhere greater than 0, of course, but less than 1, we're going to end up with an ellipse. If that E happens to equal 1, it's a parabola. If E is going to be greater than 1, we get a hyperbola. So if we focus maybe in on the parabola can be thought of in terms of a locus definition. is a set of all points equidistant from a line we call the directrix and a point we call the focus. So if I think of all the points equidistant from both of those, we would have a parabola. And we know that's our definition of a parabola. If these happen to be equal, there would also be a point here that is right in between the vertex, the focus, and this line called the directrix, and we, of course, call that the vertex. Now, if we happen to have E that is less than 1, for example, maybe 1/2, what we would end up with, of course, is an ellipse. Because from N, let's say the P is right here, from N to the P and N to the F would be twice as far. And then, other way around, from P to the F, and then P to the N would have to be twice as far, so it would have to be either way over here or way over here. So as we go through these different relationships, we can kind of build the locus definitions. And again, that's not something that's very, very common for a lot of people, so I just wanted to point that out as being something a little bit different. In terms of the conics, there are different ways we can write them. There's very general ways with certain coefficients, but basically they're going to have x's and y's, x squared, y squareds. This is the only one that only has the x squared or y squared. Completing the square is going to be important in terms of looking at conics. I like to think of a general conic that's going to look like this. Ax squared plus bxy squared plus cx plus dy plus e equals, you could just say 0. There are different versions of this. Of course, you might notice, what about some xy terms? We're going to take care of those. But for now, this is one way we can think of a general conic. What do you have to be able to do? Well, it goes back to pretty much my 3 relationships. You might be given the equation of the conic. And you're going to have to be able to come up with the graph. Or you may have to come up with all the stuff. The stuff being, maybe you happen to know the equation of a parabola and you need to find the focus and directrix and vertex. Or maybe you have the equation of an ellipse and you have to find the 2 foci, the 2 vertices, the major axis, the minor axis, the latus rectum, and maybe even some other things. You might be given the equation of hyperbola, and you would have to find, again, maybe the center, the foci, the 2 vertices. The major axis is called the transverse axis for the hyperbola. We have the off axis being the conjugate axis. But we also have these things called asymptotes when trying to graph these hyperbolas, because it gives us basically a way to figure out how wide the hyperbola is. So that's one thing. Or you might be given the stuff, and you have to figure out the equation and the graph. So if I tell you all of those things, can you write the equation? And then lastly, maybe you're given the graph. And you can look at the graph and realize, I know where the center's at, I know where the vertices are, so now I know what the equation would be. I'm not even going to write down what the equations of these are, because you can look in the book. These two, we're going to have a sum of 2 fractions, usually, or a difference of 2 fractions equaling 1. That's kind of that general standard form. Circle, we pretty much know about. X squared plus y squared equals some number. Of course, if it's shifted left or right, up and down, we're going to have some numbers within the function x squared or y squared to indicate those shifts. So, it's a lot of information, and then in some ways maybe no new information. But one thing I did want to point out is that this eccentricity is a neat way to think about conics. If you've looked at eccentricity a little bit differently in the past, it's still fine. I think in the past it was mainly used to describe the difference between an ellipse and a circle, and how how much like a circle an ellipse could be. So basically, that's what we have for today. Most of this was also just to make sure that you can access these videos. I will try to continue to, on a weekly basis, update things through an email. I will use the update feature on Schoology to give you any other middle-of-the-week type things. But for the most part, look at the calendar that I just try to do what I ask you to do each day. And as I get more information about the test, I will pass it along. Eventually, up through N, maybe not quite sure which ones, I'll have a handout for you to work on and get back to me. The one you're currently working on, whenever you do have that finished, you can scan it to me or send it through a picture, and I'll get some feedback on it, at least get a grade for you. So that's all we have for today. Look forward to more messages, and I hope you're doing well.